We've looked at solving systems of linear equations using graphing, where we found the point of intersection. We also looked at the substitution method, and now we're going to look at a third method, again, that always will work for you, called the elimination method. And what we're going to do first is we're going to take our two equations and make sure that they're lined up with each other. Meaning that, like if we have 2x plus 3y equals 7, and x minus 5y equals 8. All the pieces are stacked on top of each other. The equals are right above each other. The numbers that don't have a variable are by themselves. The y's are stacked on top, and the x's are stacked on top. If these equations aren't written this way, if they're not in the standard form for a line, it's important that you get them so that they're lined up this way before you go any further. And then step 2 is using multiplication, we're going to get opposite coefficients. Our goal here is to pick one variable and make it go away. And to do that, what we need is we need one of those variables to have the same coefficients except opposite numbers. So maybe like 5x and negative 5x, or 8y and negative 8y, something like that. Once we have that, we simply add the equations together and we solve. And then we take the value that we just got in step 3 and we substitute it into either original equation, and we're going to solve for the missing variable. And reading these steps, it probably doesn't make a whole lot of sense right now, but let's get into a few examples and hopefully you can see how this works. We're going to do 3 of them together and we'll see how this goes. We're going to look at 3 slightly different systems. So here's our first example. We have 2 equations, and you can see that these are indeed lined up. We have the equals above the equals, and then we have the x's, the y's, and the constants. So step 1 was to line them up. We did that. Well, we really didn't, but it was done. Step 2 is we need to get opposite coefficients on one of the variables. So we pick a variable that we're going to eliminate, and there's no right or wrong answer here, but just like with substitution, sometimes it's easier to do one thing instead of another. And in this problem, notice that we have 5y in the top equation and negative 5y in the bottom equation. The y's are already opposite each other. So step 2 is done for us, and it says we now add. And we're just going to combine things together. The equal stays where the equals is. Negative 5y plus 5y, those two things become 0. Those add together, giving us nothing. Now we're left with 8x, 2x plus 6x, and then negative 17 plus negative y is 8. Now we have this really tiny, nice little equation that we know how to solve. Divide by 8. So x is 1. And now the last step of this says we take that value that we just got and we substitute it back into one of the original equations, and it doesn't matter which original equation you choose. I'm going to choose the top one simply because it doesn't have any negative values in it. And that just creates one less place for me to make a mistake with. So I'm going to put 1 in where it said x, and I'm now going to solve for y. So we have 2 plus 5y equals 17. Subtract 2. 5y is 15. Divide by 5. Y is equal to 3. And we have just solved our first system using the elimination method. All right, second example. And in this example, it's not quite as short as the last one because inspect the variables here. We have 3x and 4x, 2x, 2y, and 3y. We don't have opposite coefficients here. So what you now have to do is you have to make a choice. And there's no wrong choice. You just have to simply make a choice and commit to it and decide which variable you are going to eliminate. And it doesn't matter. It really does not matter. I'm going to eliminate the x's. I'm going to choose to eliminate the x's. So I'm going to make those things become opposite coefficients. And I do that by multiplying. So I have 3 and I have 4. This is kind of like getting a common denominator. I want those two numbers to be the same value. And hopefully you can see that, well, we can turn those both into 12. So I'm going to take the top equation and multiply it by 4, giving me 12x plus 8y equals 4. And then the bottom equation I'm going to multiply by negative 3. And I'm using negative 3 so that this x term becomes negative 12x. Remember, my goal here is to get opposite coefficients on one of these variables. And I've just achieved that with the x's. And now it's minus 9y equals 6. And again, it doesn't matter what variable you chose. If you chose to get rid of the y's, that's completely fine. Your steps are just going to look a little different. They're going to have different numbers in these equations. But you'll end up in the same spot, which is the really nice thing about this. We add now. The x's go away. They become 0. And we now have negative 1y equals 10. Divide by negative 1. Y is equal to negative 10. And the next step says we take that value and we substitute it back into one of the original equations. So step 4 says, okay, pick one. Doesn't matter again. We have lots of choices, lots of freedom on how we want to proceed through these things. Let's take the top equation. 3x plus 2 times negative 10 equals 1. 3x minus 20 equals 1. Add 20. 3x equals 21, and x is 7. So there we go. Our solution would be the ordered pair 7, negative 10. I think this method is really slick and really quick with how things just sort of fall into place. I like this method over substitution, but substitution works really nice in some situations too. Last example. This would be a decent one to solve by substitution, to be honest, because I look at the second equation and there's plain ordinary x right there. But personally, I only use the substitution method when that first step is done for me. When one of the equations is y equals or x equals. If they're lined up for me like this, I'm going to use elimination every single time. So I'm going to pick a variable to get rid of. I'll get rid of the y's this time just to be different. So I have 6y and 3y. What can we turn those into? Think about common denominator. Think about what's the least common multiple of these two numbers, 6 and 3. Well, the bottom one can turn into a 6, and I'm going to turn it into negative 6, so multiply by negative 2. So now my system is 2x plus 6y equals 18. That's the top equation. And then the bottom equation, when I multiply by negative 2, becomes negative 2x minus 6y equals negative 18. And now when I add together to make my y's go away, look at what else happens. 2x plus negative 2x, those also go away. So on the left-hand side of this equation, I have 0. On the right-hand side, 18 plus negative 18 is also 0. We saw something similar to this with substitution. The variables are all gone. You have to ask yourself, is this a true statement? And the answer here is yes, 0 does equal 0, so there are infinite solutions. If you ended up with a statement such as 0 equals 12, that's nonsense. We would say that there's no solution in that case. So this is our last method. With some practice, very, very, very manageable for us to do. You have to be organized and thoughtful and understanding that you can do this problem very different than your neighbor and still both be completely correct.